Hello students, welcome to Daily Chemistry Dosage. In this video, I will explain how to predict the shapes of molecules when lone pairs are present. Already I have posted one video regarding the shapes of molecules when there are no lone pairs. Okay, so this is the video regarding the shapes of molecules when lone pairs are present. Carefully watch the video, then you will get a clear idea about the shapes of molecules. So let us revise our previous topic, that is when there is no lone pairs. See the table here, you have to keep it in mind. So electron pairs is equal to 2. Shape is linear. 3. Trigonal planar. 4. Tetrahedral. 5. Trigonal bipyramidal. 6. It is octahedral. Then, so we have to discuss one more point related to VSEPR theory. So according to VSEPR theory, the shape of the molecule depends upon 2 points. The first one is it depends upon the number of electron pairs. And second point is it depends upon the number of lone pairs. So these two are the key points to find out the shape of molecule. Okay, already we have discussed that number of electron pairs is equal to half of valence electrons around the central atom plus number of univalent atoms plus charge of anion minus cation charge. That is already discussed here. And how to calculate the lone pairs? Lone pairs is equal to electron pairs minus bond pairs. Okay, I will discuss later and how to find out the lone pairs. So let us discuss the table first. When two electron pairs are there, bonding groups are 2 and lone pairs are 0. The shape of the molecule is linear. So this is the shape of the molecule. And coming to the 3 electron groups, bonding pairs are 3, lone pairs are 0, then trigonal planar. So there is no change in the hybridization. It is sp hybridization only, and it is sp2. Whether lone pairs are present or not, it does not affect the hybridization. Okay. So when the lone pairs are present, how the trigonal planar is distorted, that we discuss now. So coming to the 3 electron system, the expected shape of the molecule will be trigonal planar. But when one lone pair is there and 2 bond pairs are there, the lone pair should be drawn in the axial position like this, and remaining 2 are bond pairs. So what is the shape now? It is a bent shaped molecule, or you may say V shape, or you may say angular. Okay, so you should draw the lone pairs on the axial position. That is done. Okay, next, coming to the next case, that is 4 electron groups. That is when 4 electron pairs are there, 4 bond pairs, we know that sp3 hybridization, it is tetrahedral. And when lone pairs are there, then how it will affect the shape of the molecule? Because we know that lone pair, there are repulsions among the lone pairs, or lone pair bond pairs, or bond pair bond pairs. Whatever the repulsions are there, it leads to a distortion in the shape of molecule. We know that point. So depending on that point, we have to discuss the shapes of molecules. So 4 electron pairs are there, then the shape will be like this. It is tetrahedral. But when one lone pair is there, the lone pair is drawn in the axial position and remaining bond pairs are as usual. So the tetrahedral becomes a pyramidal molecule, right? And when 2 lone pairs and 2 bond pairs are there, so the 2 axial positions are occupied by the lone pairs and remaining are bond pairs. It will be a bent shaped molecule. So here also it is bent and here also it is bent. Okay, so depending on this point, we have to note one point here, that is when the shape is given, you can't conclude the hybridization. Okay, it may be sp2 hybridization or sp3 hybridization. So you have to count the electron pairs for finding out the hybridization. Got it? Now coming to the next one, that is 5 electron system. See here. So 5 electrons, 5 bond pairs, 0 lone pairs. In that case, the shape of the molecule will be trigonal bipyramidal. So this is the shape of the molecule. Okay, and how the lone pairs affect, that we discuss now. So when 5 electron pairs are there, the shape of the molecule will be trigonal bipyramidal. Like this, we have to draw like this. but one lone pair is there. You should note a point here. In case of 5 electron pair system, the lone pair should be occupied by the equatorial position. The lone pair should be occupied by the equatorial position like this. So this is the lone pair and remaining are bond pairs. What is the shape of the molecule? We can say it is a seesaw. See here. So this is the seesaw shape. This is the seesaw shape. Okay. Now, when two lone pairs are present, the two lone pairs are occupied by the two axial positions like this, and remaining are bond pairs. So what is the shape of the molecule? It is a T-shaped molecule. So the shape is T. And there is one more case here, that is 3 lone pairs are present. At that case, all the equatorial positions are occupied by the lone pair of electrons and remaining are bond pairs. Then what is the shape of the molecule? It is a linear molecule. Okay, so let's just observe the shapes of the molecules here. So this is seesaw and this is T-shape. This is linear. Okay, coming to the next one, that is 6 electron groups, 6 bond pairs, 0 lone pairs, octahedral. So octahedral is also known as square bipyramidal. You should note down this point. So octahedral is also known as square bipyramidal. So this is the shape of molecule. How the lone pair leads to the distortion. See here. 6 electron pairs and the shape of the molecule is octahedral. This is octahedral. Okay. And when lone pair is present, one lone pair is there, and you should draw the lone pair on the axial position. It is as usual. So like this, remaining bond pairs should be drawn like this. So what is the shape of the molecule? It is a square pyramidal, or you may say it is a distorted octahedral. Okay. Then when two lone pairs are there, then the two axial positions are occupied by the lone pairs like this. And remaining are bond pairs. What is the shape? It is a square planar molecule. Got it? So see how simply we can draw the shapes of molecules. If you know this table, you can easily find out the shape of any molecule that is given. Okay, so let us solve few examples. Before that, I have already told you electron pair should be calculated and lone pair should be calculated. So we know the formula for the electron pairs, that is half of valence electrons around the central atom plus number of univalent atoms plus anion charge minus cation charge. We know this. And lone pair is equal to electron pairs minus bond pairs. And there is a question, what is the bond pair here? So how to find out the bond pairs? Simply bond pairs are nothing but number of atoms around the central atom. So bond pairs are nothing but number of atoms around central atom. Okay, let me say PCl5. So there is a central atom phosphorus here. How many atoms around the phosphorus? 5 chlorines are there. So you may say 5 bond pairs are present. In case of methane, you may say methane. In this case, 4 hydrogens around the carbon. So 4 bond pairs are there. And if it is H2O, so how many bond pairs are there? 2 bond pairs are there because 2 hydrogens are there. Whether it is bivalent or univalent, whatever it is, you have to count the number of atoms. That's it. Okay. So coming to the examples, the first example, a well-known example, that is water, H2O. So the first step you need to do is electron pairs. So how many electron pairs are there? Half of valence electrons of oxygen, 6 plus 2. So it is 4. Hybridization is sp3. So according to the hybridization, we may expect that it is tetrahedral. But you have to check the lone pairs. So lone pairs is equal to 4 minus bond pairs. How many bond pairs are there? 2. So 2 lone pairs are there. So the shape of the molecule will be tetrahedral like this. But because of the lone pair is occupied by the axial positions like this. And the remaining are bond pairs, then the shape becomes bent shape, or you may say V shape. Okay. Another example for you, that is PCl3. In this case, phosphorus is the central atom. So number of electron pairs are half of phosphorus belongs to fifth group, so 5 valence electrons are 5, univalent atoms 3, charge 0. Now it will be sp3 hybridization because 4 electron pairs are there. So let us go for the lone pairs, that is 4 minus bond pairs 3, 1 lone pair. So 4 electron pairs means it should be a tetrahedral molecule, but because of the lone pair the shape will be like this. So it is a pyramidal molecule. So in this way we can draw the shapes of molecules. I will give you one more example. So that is ClF3. In this case, half of 7 plus 3, so 5 sp3d, and next step is for the lone pairs, 5 minus 3, it will be 2. Then the shape of the molecule is, so this is trigonal bipyramidal, and you have to put the 2 lone pairs in the equatorial positions. It will be like this, and remaining I will draw another structure for this. So this is lone pair. This is the shape of the molecule. So what is the shape of the molecule? It is a T-shaped molecule, right? So you can write it as a T shape. What is the hybridization? sp3d hybridization. Got it? So in this way we can easily solve the shapes of molecules. So if you have any doubts regarding this topic, you can write in the comment section, and I have given few examples in the previous slide. Try to solve those examples also. Thank you very much for watching my video. This is Jyotsna signing off.